Hi and welcome to this video. In this video I will do a walkthrough of deploying a new private Ethereum based blockchain in the cloud, complete with miners or mining nodes and all the infrastructure needed. So if you're not familiar with what Ethereum is, or the Ethereum blockchain, this is it here. I recommend you go to this website and read all about it. You can find the people behind it, and there's a lot of great information down at the bottom. You can get the information, the code on GitHub. You can meet developers, and all the information's there. So recently, just a few days back, this is 23rd, this got published, or it got updated on the 20th. And it's an offering from the Microsoft Azure team, or maybe not the Azure team, but certainly it's for the Azure platform, Microsoft's cloud. And what they've kindly done is they've created a template based on Ethereum, and I'm going to walk you through that in just a second here. Again, you can find this over on GitHub, in Azure, and your quick start templates. You can find this particular template. The one we're working with today is the Ethereum Consortium blockchain network. That is a private blockchain. And if we just scroll down through the README page, have a look at the overview, and get a good idea of what it is we're doing here. Essentially, the template will deploy and configure a private Ethereum network on Azure, and of course it says here, obviously for an enterprise you might want to configure it before you build it out, but we're not going to go into the customization of it right now. We're just going to deploy it as it is, and what it will give us is, let's have a look. I did read it earlier. Essentially, this is the architecture here. This is what we're going to be standing up in this video. So you've got 4 subnets here. You've got, looks like a web app for the admin and the users. This looks like a load balancer with some transaction nodes, and they are isolated then from the mining nodes, I guess. So let's just have a look at what else it says here. Network consists of a set of shared transaction nodes which an application can interact with and submit transactions. So the brilliant thing about the Ethereum blockchain is this ability to create smart contracts, and the ability to build these decentralized distributed apps that run contracts and run code on the blockchain, essentially. So it's one of the powerful features that comes with this, and what has a lot of people interested. So I guess from this architecture, you can build applications that interact with these nodes via the load balancer. It could be within another subnet within your environment. It could be an external third party, and they can interact with these nodes. The actual nodes back here are, it just shows you there could be more as you grow. These are obviously isolated from the public. These are obviously available via the load balancer. So what else? Let's have a look. Yeah, so all nodes are within the same virtual network. Each consortium member. So if you are building this private blockchain environment for a project that consists of the blockchain infrastructure for a specific project in mind, where you have different vendors that come together. They each can have their own subnet and their own node essentially in there. And they configure to the application gateways. So we're going to dig into this a little bit more. I'm not going to go through all of this information. I just recommend you go here, read it yourself, understand exactly what it is we're doing here. I guess I just want to stand it up and show you how it looks. But all the information is on here regarding mining nodes, what transaction nodes are, and what their purpose is within the blockchain environment. We've got how to configure Ethereum. Also, one thing I want to just point out here is it says here the mining difficulties depend on the number of mining nodes deployed, and also the pre-configured account within this particular template has 1 trillion ether to seed this private blockchain. Now, in an enterprise, you might have different ways you want to configure this, or in your project you might want to configure it a different way. So really this can be configured, but at the moment we're just going to go with the default, and we will end up with something like this, showing our nodes and address and stuff with ether in it. And then we'll show you how you can interact with this, how you can point a wallet at it, and how you can sort of transact. So we can go from here, or we can go from here. I'm guessing both go for the same place, so I'll click this one. And where it's going to bring me to is the Microsoft Cloud, the Azure portal. And let's just give it a second. Okay, so as you see, I am in custom deployment. It's got my subscription, it's got my new resource group. So I am on parameters at the minute. So let's have a look what it says. String used as the base for naming resources. Okay, so let's call this Earth Cloud. I'm going to stick with the default username. I'm going to give it a password. Okay, so let's have a look. myetherwallet.com January. Okay, so myetherwallet.com. Okay, so let's go there. Wallet.com. Okay, so I hope I remember that. Okay, my wallet's been generated. I'm going to download the key store. I'm going to download the JSON file, and this is my private key, which I'm going to transport over here. No, here. Cool. And they're going to leave the default there. They do recommend in the documentation here that you put a large number. It doesn't say here, it says in the other one actually. Choose a large number. I'm just going to leave the default because we're going to tear this environment down when we're finished. So consortium members, so it's going to be myself, a imaginary partner in this particular project, and the mining nodes. So let's have a look. So consortium member, each member receives a subnet with one mining node. Okay, so depending on the number of vendors in the project, depending on the potential number of partners that maybe have a stake in this particular blockchain, they all get their own subnet, they all get their own mining node. So, and again, every time you put a number here, it's going to cost. Each node is going to be an instance of a virtual machine. It's going to have some kind of type of that, and it's going to cost. So it's really down to your particular needs. I'm going to leave it as 2 as a default, and the number of additional mining nodes. So this is okay. So everybody gets 1. That's the default, and you can add additional mining nodes to each consortium member. And of course, miners process transactions, collect fees, mine the blocks. So separate to this call, or this presentation, there's much information out there on mining. So let's see what it says here. Total mining nodes. Total mining nodes equals the number of the consortium members plus the number of consortium members multiplied by additional mining nodes. So I'm conscious of the cost of adding additional nodes, additional servers, so I'm just going to leave it as the default there. And here we get to choose the size of the virtual machine. Let's see what options it gives me. Okay, so they're all there. Let's see. Okay, so I will start with, I think, standard D ones. Okay, so before we choose them, we're just going to take a look at what they are. Okay, so we have the D series. Okay, so we've got sizes A, D, DS, F, FS, G, and GS. D series are to run applications that demand higher compute power, temporary disk performance, faster processors, higher memory to core ratio, solid state drives. DV2 falls on from the original D series, more powerful CPUs, faster. Okay, F series based on Haswell, lower price per hour, best value and price performance. Okay, and then you've got the G series for memory. A series. Okay, so the A8 to A11 sensors are compute intensive for high performance computing. F series are great for workloads for need faster CPUs, and there's the sizes. Give you an idea. So standard A, one very small. D series 1, 3.5, 1 3.5, and 3.5. Okay. I guess the main point is, what is the cost of? So do we have a price for those? Pricing. Okay, and we have a little calculator here, which is pretty helpful. So you can just punch in what it is you need. We'll just try this one. Do it pounds, do it on a monthly basis, general purpose. Okay, so you get a cost. £8, not bad. Sorry. Yeah, £8 not bad, £21 not bad. So that's general purpose, the A0 to A4, 30D, the D1s. And again, if you go back to your parameters here, so you have two nodes and an admin node. So you're talking, let's have a look, two, so you're talking possibly 5 here. So let's go with the A's, I guess. So I don't see an A0, so let's just stick with the A1. And okay, hope everything's good. I had to have a look at the edit template there just to have a look. So essentially it's a JSON file. The template's built in, and if you're familiar with AWS CloudFormation, it looks exactly the same. So you can build up your resources as a JSON file and configure it. So if you were trying to configure this template, maybe to have a different seed value or different kind of consideration, you can get under the hood essentially before you stand up the environment, and you can tweak this here. So I'm just gonna not change anything in it. New resource group, I'm going to do Cloud, just keep it consistent. I'm going to leave it WestJS, that's fine. And let's have a look at the terms agreement. So this tells you obviously by running this, obviously agreeing to the terms that it's going to cost some money when you stand it up. So I've accepted that. I'm going to pin it to the dashboard. I'm going to go create. So sorry for the longer process to get there. I just had to go through it myself for the first time, show you how it's done. So now, so it started 8:45 p.m. Let's see how long it takes to stand up this architecture, and let's see what else we get. So that's different. So let's see what it says here. So the admin site URL is the DNS name of the load balancer. Okay, so we'll have a look at that shortly. Okay, so this is what we're going to look for in just a second. So let's just review what it's doing again. We are creating a private consortium network, so that's a private Ethereum-based blockchain from scratch, where we'll generate a Genesis block. So we'll generate a brand new blockchain from day one. It'll have its own network ID, it'll have its own mining difficulty, it'll have its own mining nodes, all in the cloud, all secured and configured. It'll have one pre-configured account with 1 trillion Ether to seed this private network, so that so you can build your smart contracts, you can build your distributed apps, your decentralized apps, and you can fund those smart contracts with some of this Ether. And if you want a more detailed walkthrough, over here on TechNet, there is a PDF that was kindly published. It's also it's more or less the same information from the GitHub page, but you may as well take a look at it while you're waiting for it to provision. Wrote by Christine. She's the senior program manager there at Microsoft, I guess. So let's have a look. So a little bit about blockchain, a little bit about Ethereum protocol. So we will then be able to build our own decentralized applications that will communicate and execute logic against our private Ethereum blockchain. So this template is currently deploying a private Ethereum network with its peer-to-peer, it's decentralized network of nodes that will hold this distributed ledger, and gives us access to the smart contracting features. So they say here the nodes are divided into mining nodes and transaction nodes. Transaction nodes maintain a copy of the distributed ledger, but are used to submit or look up transactions from the network. Applications interact with these nodes using Ethereum's Web3 JavaScript object to execute and store important transactions within their application. A wallet is usually backed by a transaction node on the public network. Mining nodes process and commit transactions to the underlying distributed database through a consensus process. So this is what we get out of the box here with this template. And again, it's walking you through what we just did there. That's what we just did. Here gives you on the left what the parameter is and a little bit of information about what should be there. And of course, I was saying there that they tell you to do a higher ID. And again, there's our architecture. A little bit about mining nodes, a little bit about transaction nodes, the configuration, administration, administrator website, and then it goes into how you create an additional account. So here they reference MetaMask. And that's a cool website. I like that little fox. Yeah. So you get it as a Chrome extension. I'm just going to install it here. Cool. So MetaMask is there, and it takes you to a page that shows you how it works. I'm not going to go through that now. Thanks to Dan and Art and support from those folks. And it tells you what it is. So essentially, can I get it up here? I agree. Create a new vault. Okay, so I hope you can all see how to get into my account. Should be easy enough for you. Okay, so here's my little ETH wallet. I'm going to go to settings, and shortly in a second I'm going to point it at our private blockchain. So deployment's still going. We started at 8:45, so it's 5, 6, 7, 8. It's 8 minutes in there. So let's have a look. Let's have a little summary of it. It's looking good. So okay, create it, okay. So we are almost ready actually. 8 minutes, not bad. This one's created. It's just looking like it's needing to refresh. Everything seems to be good. I'm just gonna give it a second. Let's finish. So yeah, so once we stand up our blockchain here, so let me go back to that PDF. So here, no, it's here. Okay, so MetaMask is one, provides that identity vault you see me create there, and a connection to an Ethereum network. It could be the public one, it could be a test one, it could be our private one. And register the account in the network. Transaction, like any other transaction, will go to one of the transaction nodes and eventually be mined into a block, as illustrated here. So this is us. We point it at our private blockchain. It'll create an account there and a transaction. The miners will pick it up and process that there. So there it is. It says it'll be connected to their test network. You need to change it to the private consortium network, specifically to the load balancer in the front of the transaction nodes. From the template output, retrieve the exposed Ethereum RPC endpoint at port 8545. The second template output and enter it in a custom below. So here's an example below. So we need to find our load balancer. Let's have a look. So it still says deploying, however, everything looks like it has been deployed. Let's have a look. So I'm going to go to resource groups, I guess. I'm going to go to the resource group Cloud. So this is our resource group here. It is still deploying, but it does show everything what we have in it. Availability set, virtual machine, virtual machine, virtual machine, virtual machines. 1, 2, 3, 4, 5 VMs. And remember, each of those will have a cost for it per hour. So whatever it costs for a month, let's say it costs, what do we pick, A1. So A1, £21 times 5. So you're talking £100 a month, 20, 40, 60, 80, 100. You're roughly talking, for that default setup, £100 per month just for the VMs. Then we have a load balancer. Then we have network interfaces. 5 of them, so I guess 1 for each VM. And I'm guessing here we have miner 0, miner 1, miner 2, miner 3, 1 for each consortium, or sorry, 2 for each consortium member. And I guess this is the transaction node that's publicly facing via the load balancer. There are the interfaces. Then we've got security groups. We've got 2 public IPs. We've got a load balancer IP, and we've got a transaction node public IP. We also have a private network here, a virtual network, where all these VMs will exist on a different subnet. And we have 2 cloud storage accounts. So that's it, set up. I'm wondering if this is just a bug, or is there something that hasn't been deployed. Let's have a quick look through here. Okay, succeeded just now. Okay. Resource costs. So there was me trying to set it up. This particular feature that I just came across there allows you to see what the current spend is. You can actually control and see what your whole blockchain, your whole private Ethereum based blockchain is costing you to run, and you can see where the spend goes. That was our template. That was the security groups and some VM extension. Okay, so I think we're good. Excellent. So there we go. So I say it's probably all set up in around 8 minutes. Maybe there were some checks, but less than 15 minutes there we have a full blockchain established. So what I will do is I'll take the load balancer first of all, and I will take the properties of a load balancer. Maybe not. Let me just read that again. So, expose the Ethereum RPC endpoint. So, it's not quite clear. So, okay, so I've seen that. Let's have a look at that then. So, let's close that. What was it? Deployments. Is that one? Okay. Outputs. There's the admin site. Let's have a little look at that. Excellent. So this is our private Ethereum network. our own private blockchain with our own nodes, our own mining nodes, our own transaction nodes, our own wallet where we have 1 trillion ether in there, and we can then do what we want with this network. We can build this out into whatever we want. So transaction node, miner 0, miner 2, miner 1, miner 3, peers, latest blocks. As you can see, it hasn't created a block yet. We've done no transactions, waiting for the first block to be mined. Okay, so we are up and running. Over here is the endpoint. Here we are. Let's go back to our little meta. Okay, let's go to settings. Let's save that. Our super strong password there. Okay, yes, it's in beta, I understand. Okay, here's our wallet address in there. We obviously no ETH, so let's have a look. I'm guessing that's our wallet address. Okay. So that was pretty straightforward. Okay, so we've created our account. By creating the vault, you create a wallet containing an account, create additional accounts, select switch accounts. Okay, so we can create more in one there. So initiate an initial Ether allocation. So through the administer page, you can formulate a transaction, transfer Ether from the pre-allocated account to another Ethereum account. This Ether transfer is a transaction that is sent to the transaction node and mined into a block as illustrated below. Here we are. So the user through the admin page will request a transfer. It'll hit the transaction subnet, transaction node subnet, and it will send the transaction. Okay. So via the clipboard icon, copy the address of the wallet you want to transfer, go back to the administrator page, paste the copied account into the input. So I didn't see the input one, so let me just refresh the page. Okay, maybe because the first block hasn't been mined yet, that's probably why there's no input there. So let me go back. Okay, so I guess we just give it a second or two. So let's bootstrap a new address with we just gotta be patient a little bit. Okay, so only took an extra minute or so there, it wasn't really long. And okay, so if I paste that and I can submit. Looks like it's doing something. Okay, Ether sent. Here's our blocks starting to go, and hopefully in a few seconds after these blocks have been mined and consensus is reached, we should get some Ether. I hope I got it, the right address there. Let me just double check. Yeah, that should be the right address. I'll refresh the page to see what the stats are like. Okay, so they're all 21, they're all on consensus. Looks like these two are mining. So I guess then our little wallet should be picking up this is a cool little wallet. Just double checking here. That's fine. Okay, so it looks like blocks are starting to fill that up. Let me try that again, just in case. Will it let me send another 1,000 Ether? I wonder. Okay. So while that's waiting, let me just check in here in case I'm missing something. I wonder, do we need the port? Do we need the port number? Yeah, let's see the port number. Yeah, I did. 8545. 8545. Okay. Okay, so we get. I guess we gotta wait. So back to the admin page. Okay, so we can see it is mining away. I guess their ID is 0, this ID is 1. Makes sense. And okay, cool. So obviously I did that submit twice, so that's why I have 2,000 ETH. That would be nice if it was on the public network, but it's not. It's on our private network. Okay, so that was an example, a demonstration of using the new project, Bletchley, the Microsoft Azure template, to create a private Ethereum-based consortium network, a private blockchain, complete with mining nodes, complete with transaction nodes, network, and let me just go back here. just to give you an overview again. It established an availability set with 5 virtual machines. 1, 2, 3, 4 mining nodes, 1 transaction node, a load balancer, network interfaces, security groups, load balancer, public IP, transaction, node, public IP, a virtual network for all the virtual machines, and some storage accounts. And it provisioned that all probably in about 8-10 minutes. It took probably 14 before I was able to get in, but that's it, complete. We've demonstrated it is working. We can see our nodes, we can see the blocks on the blockchain. We simulated, we didn't simulate, we actually did a transaction. We sent 1,000 ETH twice, and now we see that they're in our wallet. And if that was public ETH, it would be worth 26,000 US dollars. So thank you for watching the video. Hope it helps you. If it did help you, if you have any questions, comments, leave them below the video. You can tweet me on Twitter, but hopefully this will help you be able to create your own private blockchain and start building some cool distributed decentralized apps to build on top of it. And if you need any help, advice, give me a shout. If I can help you, I will. Have a great day.